Any questions that you have about anything that I go through today, make sure you jot down in your notes, bring them to your lesson with me or Nick so that we can go through them. You will need your booklet today, your chapter 11 booklet. There are some questions that I would like you to do before I start going through the content, the main content of the video. We will mark those at the beginning of lesson 11.2. All right then, so I need to share my screen, don't I? And then I will take you to the PowerPoint. Okay. Right, the first thing you need to do is you need to go to your booklet and you need to find this page here where you have these different molecules with the names of them underneath. I think that's on page 9, you'll find it. So what you need to do is you need to look at those molecules and you're going to need to really think, because underneath each molecule is the name of the molecule. And by looking at them, you might be able to figure out some of the rules of how to name these molecules. Chemists use a really strict naming system for naming molecules, and it's the same one that should be used in laboratories around the world. The naming system was developed by an organisation called IUPAC, which stands for International Union of Pure and Applied Chemistry. The fact that it's international then means that I could talk about cyclohexane on the phone to a chemist in Costa Rica and they would know exactly the molecule I was talking about. So you're going to look at those, pause the video for 2 minutes, think about what they're named, why they might be named it. And once you've done that, you're going to have a go at the questions just below it in the booklet. So that is going to be questions from that table, so 1 through to 15. Take your time with those, pause me and then unpause me when you're ready for me to tell you what the rules are. Okay, so here we go. These are the International Union of Pure and Applied Chemistry rules for naming hydrocarbons, also called nomenclature. Okay, so the first thing you're going to need to do when you name a molecule is find out the correct ending. I'll show you how to do that in a minute. You need to look at what the longest carbon chain is. You're going to need to assign numbers to each carbon of the parent chain. And then you are going to need to attach a stem that tells you how many carbons there are in the longest branch of that carbon chain. If it's a cyclical molecule, you just put the word cyclo on front of the name of the molecule. And then, yeah, if there's branches, we need to add the names of the branches. You're going to do that alphabetically. And if some of the branches are identical, you can bundle them together. So if we have 2 methyl groups, for example, you could call it dimethyl. If we had 3 methyl groups, trimethyl. Now, those rules, obviously I went through at the speed of light because they're not going to be that useful for you to just hear listed. What I need to do is show you some molecules and show you how we can apply these rules. If you wanted to go over those rules in your own time, obviously you're welcome to pause this video. You can jot them down somewhere. Okay, so here's a molecule. Looks really, really complicated. The reason is then we can apply as many of those rules that I've just gone through as possible, and you can see how they're used. So the first thing that we want to do is find out what the functional group is in this molecule. Have a think. Okay, hopefully you all said alkene, because we've got a double bond just there. So the ending is going to be ENE. We're going to have an ene ending because we have an alkene functional group. Then what you need to do is you need to find out where the longest carbon chain is. That long carbon chain, the longest carbon chain, must contain the functional group. So have a look, see how many carbons you can join together in a row. We go this way, 1, 2, 3, 4, 5, 6, 7. We get 7 in a row, but it doesn't contain the functional group, this alkene here. If we go this way, 1, 2, 3, 4, 5, we get 5 in a row. If we go this way, 1, 2, 3, 4, 5, 6, we get 6 in a row. If we go this way, 1, 2, 3, 4, 5. Again, we get 5 in a row. So the longest carbon chain then, with the alkene functional group in it, is this chain here. Now you might think, and you probably will think initially, that you're just looking for the straight chain. You're not. These single bonds, when we build mods, you can see they can move around all the time. So if you have to go around corners like that, that's absolutely fine. Okay, so then what we want to do is put numbers on each carbon of that longest carbon chain that we've just identified. Start with the functional group end of the carbon chain. Obviously, you can count them from left to right or right to left, it doesn't matter. But you want to start with that functional group in this case, because that's the highest priority part of the molecule. So, put the numbers on. There we go. We've named that carbon number 1, carbon 2, carbon 3, carbon 4, carbon 5, and carbon 6. The purpose of that is that you can see, obviously, we've got some other, what we call branches, sprouting off this long chain, and we need to include those in the name. So we've got the stem of the name. Because we've got 6 in a row, the stem is hex, like hexagon. And we've got these side chains. We've got 1, 2, 3. Now they're calling them side chains here. You'll often see them called branches. Either is fine. So these ones here with 1 carbon, hopefully you'll have figured out what these ones are called. These are called methyl groups. And these with 2 carbons, these are called ethyl groups. So then you want to attach the names of those branches to the molecule, to the original molecule's name, alphabetically. So far we know that this is called hexene because we've got the alkene functional group and it's 6 carbons long, so hexene. Then we've got an ethyl group and we've got a methyl group. We've got 2 of them. So decide which one comes first alphabetically. So the ethyl goes right at the front of the name. Let's talk through it. So we've got 2 ethyl because the ethyl group is on the 2nd carbon. Then, and this is not correct yet, but we've got 4 methyl, because we've got 2 of these methyl groups attached to carbon number 4. And then we've got the hex 1-ene. And the 1 there is because the double bond comes after carbon 1. Now, because these 2 methyl groups are similar, we can put a prefix in front of the methyl. See if you can remember what it was. So it's going to be 2-ethyl 4,4-dimethyl hex 1-ene. Some of you will put 2-ethyl 4-dimethyl hex 1-ene. Chemists will need to know exactly which carbon each of those methyl groups are on. So you say 4,4 because both of these methyl groups are on carbon 4. Notice when you've got numbers, they're separated by a comma, and where you're linking sort of words to numbers, they're separated by a hyphen like that. This is the only part of chemistry where it is completely important that you spell the names correctly. Normally chemistry is a little bit forgiving with your spelling as long as you make yourself understood. Here you need to spell these exactly right. You'll get a feeling for how you spell them. As you practice more and more and more, it will become second nature. Okay, so have a go at naming these compounds here. You need to recap how we named the last one, just rewind. Pause me and then unpause when you're ready. So the first one we had 3,3-dimethyl pent 1-ene. This one here, next one, we're going to have 3,3-dimethyl pent 1-ene. You can see how it's possible to draw the same molecule out in slightly different ways. And then this one here looks crazy complex. Just find the longest carbon chain that's got the alkyl group in it. So we've got 5-ethyl, 4-methyl, hept 2-ene. Hept being the stem if you've got 7, 2, 4, 6, 7 carbons in your longest carbon chain. Okay, let me see if there's anything else I want to go through before you do the lesson. Okay, here we go. So You will need to know the way that we name lots and lots of different functional groups. This table here is quite useful because it's got the name of the functional group and it's got the order of importance as well. So alkene and haloalkane should be swapped over here. So very basically, these are the names of the functional groups. Hopefully you went through those last lesson. This is the formula of each functional group down here. So haloalkanes or halogenoalkanes are compounds with a halogen joined to one of the carbons. Alcohol's got an OH group. Aldehydes have got this carbonyl right at the end of the chain. Ketones have got a carbonyl in the middle of the chain. Carboxylic acids have got this C double bond OH at the end of the chain. So if you have an alkane, the name of the molecule ends in ane. If you have an alkene, it ends in ene. With haloalkanes, we don't put anything at the end of the name, we just put fluoro, chloro, bromo or iodo at the beginning of the name. Alcohols ideally end in ol. However, if there is an aldehyde or a ketone or a carboxylic acid also on that same molecule, the alcohol group gets demoted and it becomes a prefix. So we have hydroxy at the beginning of the name rather than ol at the end of the name. Okay, so aldehydes end in al, like ethanal. Ketones end in one, like propanone. And carboxylic acids end in oic acid, like propanoic acid. Okay, so we've done that one. Okay, the minute you feel like you get the hang of this, you can go off, you can try some more of those textbook booklet questions. This one here, have a look at it. See what functional group we've got here. Go back over that table if you need to, there'll be one in your textbook, chapter 11.2. The functional group that we have is a alkane, and we've got 5 carbons in a row. Because they're joined together in a circle, can you remember the prefix? So it's going to be cyclo. 5 carbons, so it's pent, and it's an alkane, so it's ane. So we've got cyclopentane. This example here, you should be able to spot, we've got an alcohol functional group. So with this, find the longest carbon chain, 5 long. So we're going to have pent. And then it's going to have an ol ending, but so that we know whether the OH group is on the first or the second or the third carbon, we need to put the number, which is called a locant, L-O-C-A-N-T. So we give it a locant, we would say pentan, get it all here, pentan 3 ol. If we have an alcohol group on this thing that's numbered carbon 4, you want the numbers to be as low as possible. So you would just count the carbons from right to left instead. We used to say this is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. Okay. Example 3. So what functional group have we got here? Got an aldehyde. So you've got the longest carbon chain, which is 4. Okay, so we've got the bute prefix or the bute stem. At the end of the molecule, we've got al because we've got an aldehyde. So the way we form that into a name is we would say butanal, like that. So we've got the butan and then the al for aldehyde. Okay, here we have got chlorine, we've got bromine, and we've got a carbon chain that's 4 carbons long. So you want to number them, start this end, because then we've got number 1 and 2 for the carbons that we've got our chloro and our bromo on. If we numbered them from this end, 1, 2, 3, 4, we would have 3 and 4, okay? And we want to keep the numbers low. So there we go. So we are going to have the stem of the name being bute. The ending, because we've got an alkane, is butane, and then these 2 halogens will go as the prefix. they've got to go in alphabetical order. So we would have bromo and then chloro. So we are going to have 2 bromo, 1 chloro, butane. Okay, as soon as you get the hang of these, finish your booklet questions. All right, so this example here, you want to look for the longest carbon chain. It's got to include the functional group. So we've got 3 carbons here with the OH on this one, or we've got 3 carbons here, or we could go this way, 3 carbons there. Obviously, we've got to use this one because it's the one with the OH on. Okay, or you could go this way. This is also fine. Okay, so we've got 3 in a row, either 1, 2, 3 or 1, 2, 3, same thing. And you want to number the carbon with the hydroxyl group on as the lowest carbon. So that's carbon 1, carbon 2, carbon 3. Again, this could be carbon 1, carbon 2, carbon 3. So the stem is going to be prop. The ending is ol because we've got alcohol, so it's going to be propanol. We've got a branch here, haven't we, or a side chain on carbon 2. Or you could call this the branch if you're talking about this is your chain. So either way, on carbon 2, we've got a methyl group. So we are going to have 2 methyl propan 1 ol. So that we know that the alcohol group is on carbon 1. All right, this example here, see if you can do it, pause, come up with the name, and then unpause, see if you get it right. So we've got a 2 carbon chain. There's nothing else going on apart from 4 chlorine atoms, so it's going to be ethane. And then we've got to find room for those 4 chlorine atoms at the beginning of the name at the prefix. So we've got 4, which means we are going to have tetra for 4, tetrachloroethane. Because we've got 2 on each carbon, we need to make sure that everyone understands there's 2 on the first carbon, 2 on the second carbon. So we're going to put 1, 1, 2, 2 hyphen tetrachloroethane. If we didn't have these locants here, then you wouldn't know whether there was 3 on this one and 1 on that one or whatever. Okay, here we go. This is a good example. So here we've got skeletal formulae. Hopefully you had a look at that last lesson actually. So every time this straight line bends a corner, you know you've got a carbon atom with hydrogens attached, depending on how many bonds it's already got. So here we've got a carbon atom. This has got 1, 2, 3, 4 bonds, so there's no hydrogens on that one. This is a carbon atom here. It's got 1, 2 bonds, so there's room for 2 hydrogens on that carbon. This functional group, see if you can identify it. Got a carboxylic acid, and here we've got a hydroxy group or an alcohol group. The alcohol is less important, it's a lower priority functional group than the carboxylic acid, say IUPAC. So stem is going to be F because we've got 2 carbons. It's going to be ethanoic acid because we've got carboxylic acid. And then on the second carbon, this being carbon 1, this being carbon 2, we've got a hydroxy group. So 2-hydroxy ethanoic acid. Okay. So that's it. There are lots of keywords for you to have a look at. Hopefully you're going to be familiar with a lot of these from just going through this video. Once you've been able to do this many, you'll probably be able to logic and sort of reason out most molecules that get thrown at you now. So make sure you've had a go at those questions that I've asked you to do in the booklet. When you come in the lesson, you'll be well versed on nomenclature. You can ask me and Nick any questions you have, and you'll be ready to think really hard during the lesson and try some pretty difficult examples. Well done.